Good morning, all. Myself Mamta. Today I am going to discuss a topic on thermodynamics. So, in that review of laws of thermodynamics, and let us discuss about different processes. Thermodynamics is a branch of science which deals with the interconversion of heat energy and mechanical energy. So, that is, mechanical energy can be converted into heat energy, and heat energy can be converted into mechanical energy. So, before going to state the laws of thermodynamics, we should know the meaning of certain terms. System. A region in space or the portion of matter enclosed by some boundary is known as system. Surrounding. Boundary outside the system is called surroundings. Thermodynamic equilibrium. If a system is under thermal, chemical and mechanical equilibrium simultaneously, then the system is said to be in a thermodynamic equilibrium. Thermal equilibrium. If the temperature remains the same at every point of the system, then the system is said to be in thermal equilibrium. So that is, in a system, at different point, if you measure the temperature, so then the temperature remains the same. Chemical equilibrium. If the chemical composition is same throughout the system, then the system is said to be in chemical equilibrium. So next, mechanical equilibrium. If the forces acting on the system at every point is same or no unbalanced forces acting on the system, then the system is said to be in mechanical equilibrium. So if the system is in thermal, chemical and mechanical equilibrium, then the system is said to be in thermodynamic equilibrium. So next, thermodynamic process. A process in which the system undergoes a change of state is known as thermodynamic process. So next, internal energy. The sum of kinetic and potential energies of the molecules of a system is called internal energy. So before going to state the first and second law, so we have to state zeroth law of thermodynamics, which is very basic law. It states that if two systems are in thermal equilibrium with a third system, then the two systems are also in thermal equilibrium with each other. So this law gives the definition for the temperature. So if Ta is the temperature of the system A and Tb is the temperature of the system B and Tc be the temperature of the system C, if Ta equals Tc and Tb equals Tc, then according to the zeroth law, we can say that Ta is equal to Tb. So that is, system A is in thermal equilibrium with the system B. So this law is very basic. So next, first law of thermodynamics. The law states that the amount of heat energy given to the system is equal to the sum of increase in the internal energy of the system and the external work done. Let dQ be the amount of heat given and du be the increase in internal energy and dW the external work done. Then according to the first law, so mathematically we can write dQ equals du plus dW. This first law is based on the conservation of energy, but this law does not give does not tell anything about the direction of flow of heat. Second law of thermodynamics. We have two statements. Clashes statement. It is impossible for a self-acting machine unaided by an external agency to transfer heat from a body at a lower temperature to a body at a higher temperature. That is, heat cannot by itself pass from a cold body to a hot body. Second, the Kelvin statement. It is impossible to derive a continuous supply of energy by cooling a body below the coldest of its surroundings. So the second law speaks about the direction of heat. So whether the heat flows from hot body to cold body or cold body to hot body. So now let us discuss different types of process. First, the isothermal process. The process in which the temperature of the system remains constant throughout the process. So we know that from first law of thermodynamics, the mathematical equation is dQ is equal to du plus dW. In isothermal process, temperature remains constant. So if temperature remains constant, there will be no increase in internal energy. That is, du will be equal to 0. Therefore, dQ is equal to dW. Second, adiabatic process. The process in which no heat is allowed to enter or leave the system. So here dQ equals 0. So then according to the first law, we have 0 equals du plus dw, or du, increase in internal energy, will be equal to minus dw. Third one is the isochoric process, the process in which volume remains constant. So we know that the work done dw equals pressure P into dV, change in volume. Here, since the volume remains constant, change in volume dV will be equal to 0. So therefore we have dq is equal to du. So next is the isobaric process, the process in which pressure remains constant. Then according to the first law, we have dq is equal to du plus dw, or dq is equal to du plus pdv. So next, reversible process, a process which can be retraced exactly in the opposite direction with the transfer of heat energy into work and vice versa, is known as reversible process. Next, irreversible process, a process which cannot be retraced exactly in the opposite direction with the transfer of heat energy into work and vice versa, is known as irreversible process. And the last is the cyclic process, a process in which a body or a system undergoes a series of changes and finally return to its original state or initial state. Then such process is called as cyclic process. Thank you.